All right, guys, welcome to the basic algebra review. If you've already seen the unit conversion review, you know I'm sitting out on a dock in South Georgia. It's the only quiet place I could find, and it's a little windy sometimes, so I hope that won't be a distraction. Let me know when you watch this video if you're having trouble hearing the audio. So anyway, let's just do a quick review of some basic algebra things. I've just got some equations, simple equations written out here, and so I want to review these things. These concepts very quickly, and then we'll go and do a little deeper dive. Just for the type of algebra stuff that you're going to need to remember for chemistry, all right? Things we don't have time to review throughout the year because we're going to kind of jump in and start knocking chemistry out. So anyway, let's look at this first equation here, x plus 2 equals 3, all right? We want to solve for x, okay? So again, these are super simple. I don't mean to insult your intelligence. I just want to make sure you didn't miss any concept along the way. A key thing you have to always remember with algebra is anytime you're working with equations, whatever you do to one side of the equation, you have to do to the other side of the equation. Whatever you do to the left side of the equal sign, you have to do to the right side of the equal sign, right? So if we want to get x all by itself here, what we're going to want to do is we're going to subtract the 2, right? X plus 2 minus 2 equals, and since we subtracted 2 from the left side, we've got to also subtract 2 from the right side. Okay, so these 2's are going to cancel out here, and you're going to be left with x equals 3 minus 2, or x equals 1. All right, so that's the value of x for that particular equation. Now, you may have learned to do it a little differently. There's different options, and so you could do it this way. This may be a little simpler for you to visualize and make sure you don't overlook something. You can say, I want to subtract a 2 from this side of the equation, so let me also subtract 2 from this side of the equation. So we'll do a line here like we're doing subtraction, and so these 2's are going to cancel out, so we're left with x here, and then we have 3 minus 2 on this side is 1. All right, so that's a perfectly valid way to do it as well. Whatever's easiest for you. Let's do this one. X minus 4 equals 2. Here we want to get the x by itself, but we're going to have to add a 4. So over here we subtracted a 4. Over here we're going to add a 4. If we add to one side, we have to add to the other, right? So x, let's see, we'll do it the second way I showed you. Add a 4 here, and then we'll also add a 4 here. And so x, because these 4's cancel out, equals 2 plus 4, which is 6, okay? All right, what about multiplication and division? In this particular example here, we've got 4x equals 16. How are we going to get the x all by itself and get rid of that 4? Well, we're going to divide this side by 4, okay? So just like before, when we added or subtracted, if we do it to one side of the equation, we have to do it to the other. Here, we divided by 4 on the left side, so let's also divide by 4 on the right side. These 4's will cancel out. And so we're left with x equals 16 divided by 4, which is 4, so x equals 4 in that example, all right? And then in this scenario here, the way that we're going to get rid of the 3 here so we can get this x all by itself is we're going to multiply, all right? So if we multiply by 3, remember any number could be also represented by that number over 1. So if it's easier for you to think about it like that, then that's fine. But we need to multiply by 3 here because we want these 3's to cancel out, okay? But since we multiplied by 3 on that side, we have to also multiply by 3 on this side. So x is going to equal 3 times 3, which is 9. And then finally, here's one that a lot of students can kind of handle those basic equations that we just did, but this one's pretty simple too, but when the variable's on the bottom of the fraction, it seems to throw some students just have a difficult time with that. So it's the same steps, it's just we're just going to take 2 steps here to do what we did in 1 step in the last problem. So we're going to multiply by x, okay? If we multiply by x, that means these x's will cancel out here, right? But we need to also multiply by x on the other side, right, for x. So we've got, let me just come over here so I'll have a little more room. So we've got, I'm trying to turn my head so the wind doesn't blow into the microphone. We've got 12 equals 4 times x, okay? So now we've got a problem that's basically looks like this one that we did here, right? So we divide both sides by 4, and when we divide both sides by 4, we get 12 divided by 4 is 3. On this side, the 4's will cancel out, and we're just left with x, and so we see that x is going to be equal to 3, okay? So those are basic algebraic concepts that you have to be familiar with. You need to be able to work with basic algebraic equations. We generally don't have really complicated algebraic equations. So as long as you can do this, handle those simple ones, then you should be fine. Again, I'm trying to turn my head to minimize the amount of wind that's coming into the mic here. Maybe if I do that, that's going to block my voice. Sorry. All right, let's do something that's a little more complicated. I'm going to give you an equation that we actually will see in chemistry. All right, this is an equation. I'm not going to explain what all of the what everything means in the equation. You don't really have to know that at this point. But it's just an algebraic equation with variables in it, and you have to know how to work with those variables. So PV equals nRT. All right, this is an equation that we'll use when we're dealing with gases. And if I gave you this equation here, and I gave you all of the values for, let's say, you know, I haven't really, I haven't really thought about what values I could give this, but let's say we said that the P was equal to 2, and we said the V was equal to 5, and that, let's see, we wanted the R to be equal to 4, and let's say we said the T was also equal to 5. All right, so that'll be relatively simple. And I told you that I wanted you to tell me what the value of N is. All right, so you have to know to plug the values in that we've been given here. So I'm going to plug in a 2 for P, I'm going to plug in a 5 for V, I'm going to leave N as it is because I don't have a value for that. R is 4, and T is equal to 5. All right. These are totally fictitious and really not numbers now that I'm looking at it that you would get. Well, you could. It's fine. So let's multiply these together. We got 2 times 5 is 10. We got 4 times 5, which is 20. So on this side, we have 20n. Okay. And so just like we did before, if we want to get the variable all by itself, we're going to divide by the number in front of it. So 20, divide both sides by 20. 10 divided by 20 is 0.5. And so n is going to be equal to 0.5. Okay. What if I didn't give you any values? All right. And I just said, I want you to tell me what, I've given you this equation, or you've memorized this equation, and I want you to tell me what T, based on this equation here, what T would be equal to. Well, what you would do is you would divide both sides by NR. All right, NR. So if we do that, the N cancels out here, the R cancels out here, and we have T left all by itself. And so T is equal to PV over NR. Because there's nothing over here on this side, right, that'll cancel out when we divide by NR. So this is the actual, that would be the equation for NR. I'm sorry, that would be the equation for T based on the equation PV equals nRT. All right, let's do one more example using another equation that we will use in chemistry. And that equation is, I've written that down somewhere here. Okay, F equals 9/5 C plus 32. All right. So this is the equation for that we use to convert from Celsius to Fahrenheit. Okay. So if I gave you, if I said Celsius is equal to 25, right, and I asked you to tell me what F was equal to, what 25 degrees Celsius was. Let me write it this way. Let's say I said that the temperature was 25 degrees Celsius, okay? And I said, I need you to tell me that in Fahrenheit. So what you would do is you would plug in the, you would say F is equal to 9/5 25, that's what C is, plus 32. All right, if I do that, 5 will go into 25 5 times. So over here, I have 9 times 5, which is 40, plus 32. And so F equals 72. So 25 degrees Celsius is equal to 72 degrees Fahrenheit. Okay? But let's say I didn't give you Celsius. Let's say I gave you Fahrenheit. So how would you go about finding Fahrenheit if you only had this one equation? I'm sorry, how would you go about finding Celsius if I only gave you this one equation and only gave you what the degrees were in Fahrenheit? So let's say that I said that the temperature was equal to, we'll do 77 degrees Fahrenheit. It should have been lowercase f, that's just my, there we go. Okay, so how would we find this? Well, you got a couple of options. You could plug in the 77 right off the bat, or you could just go ahead and rearrange this equation here to solve for C, and then you could plug in the value for F. So I'm going to do it that way, just so that you're clear on how to rearrange this algebraic equation to solve for the variable C. Okay, how would we do that? Well, first of all, we have to subtract 32 from each side. Okay, so minus 32 on each side. So F minus 32 now equals 9/5 C. All right. How do I get rid of the 9/5? Well, the way to get rid of that is to multiply the fraction 9/5 by its reciprocal, which is 5/9. So if I multiply this times 5/9, since all of these are multiplied towards one another, I can do that. And my 5 will cancel out and my 9s will cancel out. So I'll be left with C, right? But remember, whatever I do to one side of an equation, I have to do to the other side. So I'm going to multiply this side by 5/9. So what that tells me is that C is equal to 5/9 times temperature in degrees Fahrenheit minus 32. So let's see what happens if we plug in our value for F now. So 5/9 is equal to 77 degrees Fahrenheit minus 32. That's going to be equal to 5/9 times 77 minus 32 is 45. And so 9 will go into 45 5 times. So this is 25 degrees Celsius. That's what C is equal to. Okay, that would be my final answer. All right, so that's it for our basic algebra review. Again, if you have any questions, let me know, and I hope to see you in class. Have a good one.